In this video, I'm going to talk about quadratic applications, specifically about projectiles. Anything thrown or any projectile has a parabolic path, so it can be represented by a quadratic equation. T is often used in place of x, and it represents time. And just like in science class, it almost always is represented on the horizontal axis. And then h or d is often used in place of y, and it represents the height or distance. So it would be on the vertical axis. So when an object hits the ground or the water, its height is always going to be, the y value is always going to be 0. And you solve it by either factoring or the quadratic formula. You can do, in some cases, the square root method, just like you could when we were solving them in our last unit when we were just solving, but we will usually use factoring or quadratic formula. And if you want to find when an object reaches its maximum height, you find the x part of the vertex. And remember that that's going to be x, or t is the opposite of b over 2a. And if you want to find what the maximum height is, you'll be finding the y of the vertex. So this word maximum, and it could also be minimum, this is what tells us that we're talking about the vertex. And remember, you're going to plug x into original equation and solve for y. In this example, after t seconds, a ball tossed in the air from the ground reaches a height of h feet given by the equation h equals 144t minus 16 squared. And there's a couple things I would do to start. I like to sketch a quick visual of what we're talking about. So if something's thrown from the ground, it's starting at the origin. So the path is going to look something like this. This is our time. This is the height of the ball. And because we know we are going to probably want to know what our A, B, and C are, I like to rewrite this in standard form. It's going to be negative 16t squared plus 144t. And if you want to, you can even add a plus 0 here to recognize that your C value would be 0. But remember that the sign stays. So this 16 that's attached to the t squared is actually minus 16 or negative 16. So the signs stick with the numbers. 144 is positive, which makes this addition here. What is the height of the ball after 3 seconds? That is just telling us that t is equal to 3. So we take our original equation, h equals, and you can use the original if you want to. This was to tell us, we rewrite it so we know that A is negative 16, B is 144, and C is 0. A lot of times the reason they write it in this form is to not have, to minimize the number of signs we have, so it doesn't really matter which way you use it. If I use the original 144 times 3 minus 16 times 3 squared, I can put that whole thing in my calculator, and I'm going to get 288 feet. We would get the same thing if we plugged 3 into our standard form equation. Next, we're going to look at when, that's a t. So that's what we're looking for. When will the ball reach its maximum height? And anytime you see the word maximum, we know we're talking about vertex. And so if you look at the notes at the top of your page, we know that t is going to equal the opposite of b over 2a, because that's like the x spot of the vertex at the peak part of our graph. And we know that b is 144, so the opposite of that is negative 144 divided by 2 times a, which is negative 16. I do recommend simplifying the bottom before putting this into your calculator. This ensures getting the correct answer, and if you divide this through, you get 4.5, and so that's 4.5 seconds. Let's plot that on our little sketch. So we can see that at 4.5 seconds, we're going to be at the peak. We don't know how high that is yet, but that's what they're asking in the next segment here is what is the maximum height? So we're looking for the h value, and we already know the time it will take. So we're just going to plug back into our original equation, 144 times 4.5 minus 16 times 4.5 squared. Again, if you're using parentheses, you can put this whole thing into your calculator, and you should get that h is 324 feet. So that's when it's hitting up here, 324, and that would be the maximum height. And that makes sense with the other answer that we got for part A. So after 3 seconds, which is right here, we're only at 288 feet, so it's a little bit lower than that. In the final part here, it says after how many seconds, so they're looking for T, so that's what we're looking for. Will the ball hit the ground? So hitting the ground tells us something about the height, and ground level is where h, or your distance, your y value would be 0. So we can go to our original equation. 0 equals 144t minus 16t squared. The first thing I want to do is look to see if there's a greatest common factor here. And 16 divides into both 16 and 144, and there's a t in both cases. So I'm going to divide by 16t, and that is going to come outside of my parentheses. This would all still be equal to 0. And what's left over is 9. When I take 144t divided by 16t, I'm left with 9 minus, and then 16t squared divided by 16 is going to leave me just a t. So I have two things that multiply to 0. Let me scooch up and make a little more room. I can set each of those factors equal to 0. I have 16t equal to 0, and I have 9 minus t equal to 0. So if I divide both sides by 16 on the first equation, I get 0 seconds, and that's where we started, but they want to know that's when it started at the ground. And now here, thinking of this logically, 9 minus what gives me 0? 9 minus 9 is going to give me 0. If you're doing this with algebra, you would first subtract by 9, and you'd end up with negative t equals negative 9, and then want to divide both sides by negative 1 to get 9 seconds. So if we look up at the graph up here, at 0 seconds is where we started, and at 9 seconds is where we end. If it starts at the ground, if you double your vertex, you should hit where you go up, because remember we have that axis of symmetry here, but not all of our graphs will start at 0, 0 at the ground. So look at the second example. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by negative 16t squared plus 64t plus 80. Draw a sketch to visualize the situation. So just like in our previous example, our x value is going to be time, and our y value is going to be height. So we can think of that as our ordered pair, t comma h. And a little sketch of this would be, we are not starting at 0. We are starting 80 feet above the ground, and so it's going to fall, and then this right here is like our lake. And so time over here, height is our vertical. So that part is the same, except for the only difference here is we're not starting at 0, 0. We're starting up a little bit because we're on the side of a mountain. So what is the height of the rocket after 1.5 seconds? So that's t. So we know that t is equal to 1.5 seconds. And we can just plug that into our equation. H equals negative 16 times 1.5 squared plus 64 times 1.5 plus 80. And so put that into your calculator and simplify. You might pause here and then see that you should get 140 feet. So after 1.5 seconds, the firework is at 140 feet. The next part asks us how long. So again, they're asking for the t value. for it to reach its maximum height, and we're always talking about vertex. So in this case, this is the x spot of the vertex, so it's going to be the opposite of b over 2a. And up here, our a value is negative 16, our b value is 64, our c value is 80, and so 64, the opposite of 64 is negative 64, divided by 2 times a is negative 16. So again, simplify the numerator and denominator first before putting this into your calculator to avoid making any mistakes. And when you divide this out, it comes out evenly to 2 seconds. So we know that the top right here is at 2 seconds. But it's not quite in the middle because we did not start, because our graph starts a little back here. Now the next question is saying, what is the maximum height? So that is saying, what is the h value when we're at time of 2 seconds? So negative 16 times 2 squared plus 64 times 2 plus 80. Again, pause here and try this in your calculator. And hopefully when you do that, you get 144, which would be feet. So up here, this would be 144. That's as high as any of our fireworks will get. The next part is asking us how many seconds again. Again, that's asking for us what is t when it's launched and the rocket will hit the lake. So that is saying, that's like hitting the ground, and that's saying h is 0. So we plug that back into our original equation, which would give us 0 equals negative 16 t squared plus 64 t plus 80. So again, I like to look for a greatest common factor. T cannot divide out of here because there's not a t here, but usually these problems will have a coefficient that can divide out. So I'm going to try dividing everything, and because this is an equation, I can divide both sides, and that 16 can cancel out. So I'm dividing by negative 16, and if you do that, you get 0 equals t squared minus 4t, because 64 divided by 16 is 4, and then 80 divided by 16 gives us 5, and its sign is also negative, and that's because I'm dividing a positive by a negative here and here. So basically all of these signs flip. So this becomes factorable. And you don't have to factor. Like if you want to, right from this start up here, if you want to use the quadratic formula with the a, b, and c that we find, you will get the same answers. So I'm looking for factors of negative 5 that add up to negative 4. That's going to be 1 and negative 5. And so if you're using the box method to do this, you'd have negative t squared minus 4t minus 5. And what we would put in here would be 1t and negative 5t. And if I look for greatest common factor in my top row, that's t. In my bottom row, that would be negative 5. In my left column, t. In my right column would just be 1. And if I double check this, t times t gives me t squared. T times 1 gives me t. T times negative 5 is negative 5t. Negative 5 times 1 is negative 5. So this all checks out. So I am able to write my factors now. So I have 0 equals t plus 1 times t minus 5. And if two things multiply to be 0, I can set each of those factors equal to 0. So t plus 1 equals 0 and t minus 5 equals 0. If I subtract 1 from both sides and from that first mini equation, I get t equals negative 1 seconds. That does not make sense, right? And if we scroll back up to our graph, it does when we look at this, because remember, we started up here at 80. And so this negative is just happening before our circumstances started. And so if I just graph the equation without thinking of the parameters of our equation up here, it would be hitting back here. So that does make sense for the equation, but it does not make sense for our scenario. So let's slide back here. And we can't have negative time in our scenario, so I'm just going to X that part out. And now on the second equation, if I add 5 to both sides, I get t is equal to 5 seconds. That does make sense, and that's going to be the answer to our equation. So it takes about 5 seconds for a firework to hit the water. Now this part is saying, do both of your answers make sense? No, they do not. We just talked about that. So cannot have negative time. And we have one more part here. How long will it take to reach 128 feet? So this again is this 128 feet. Feet is our h value. So we have to plug that into our equation. So 128 equals our negative 16t squared. We're always going back to that original equation, plus 64t plus 80. And in order to solve this, this goes back to what we've done in a previous unit. We have to, whether we're factoring or quadratic formula, we need our equation to be set equal to 0. So I got to get rid of this 128, and I can do that by subtracting. I then have 0 on the left, and that's negative 16t squared plus 64t. I've lined up my like terms, and 80 minus 128 gives me negative 48. You could do the quadratic formula right here, but I'm recognizing some factors that negative 16 can divide into all of these again. So that's where I start, is to see if this is factorable. And I'm left with t squared minus 4t plus, because the negative divided by negative is a positive, 3. So again, I'm looking at factors of 3 that add to negative 4. And so that is going to be negative 1 and negative 3. And you can put that in the box method. Or if you do guess and check, you only have really one option here. So you could do the box method or guess and check, but either way, you're going to get t minus 3 and t minus 1. We would set those factors equal to 0 and then solve for t. So in one equation, we're going to add 3 to both sides, and we end up with 3 seconds. The other equation, we're going to add 1 to both sides, and we end up with 1 second. And so this has 2 answers. On the way up and on the way down, our fireworks could be hitting at 128 feet. And if we scroll back up here to look at our graph, we can see that 128 might hit, somewhere in here, and it hits our parabola at 2 spots.